Hello everybody, welcome to another stream. How's everyone doing? It's okay as long as I don't lean forward maybe. That would do. Hey Geeko, how you doing sir? How are you? How's the project going? Awesome. It's great. Much better than good. Awesome. Let's give a quick recap of last stream just quickly. So last stream, we started on this super generalized fractal noise virtual machine that runs in the shader. Sounds like a bunch of terrible words thrown together, but that's what we're done. So it means we can make materials by just dragging some UI sliders around, and the material shader will run again and recompute the new material that you can visualize for your sphere or ellipsoid. Now, I'm going to be making it such that an artist or programmer in the future will be able to basically hand code their own shader that will run and generate a material procedurally, and also have options that they can expose to the editor. That side of things hasn't been done yet. That's what we'll be working on later. But what we're working on right now is the first shader, which is hyper generalized. It's just basically a way of selecting a bunch of different noises, combining them together in ways, and then getting a noise result and then shading it based on that color. Based on that height that you get back, or that noise, the final noise value. So the final noise value is kind of between -1 and 1, and the value will be alright. The value between, a minute, let me just here we go. So yeah, the value of the noise after you've done all your sort of noise, fractal noise, virtual machine stuff, whatever, the final value is between -1 and 1. We remap it between 0 and 1, just by changing it, just by multiplying it and adding. Then at the end, there's a gradient step. So you can imagine 0 being down here and 1 being up here. And all you do is you'll be able to select a bunch of different colors, right, for each height, if you will. So you can imagine like this is the low area of the material, and this is the high end of the material, and you can basically pick. It works exactly like this, where we have these sort of edges, and then it's interpolated between the edges, and that's all that's all we're doing for the ways of shading this in. So today we're just trying to finish it up as much as possible. There's still more features I want to add to this fractal material virtual machine thing, but it's going to be able to do a lot of things like generating kind of a ground with lava looking thing, probably like just rocks in general, and even as far as bark, maybe bark, like tree bark. So we're going to try and generate tree bark today, just basically providing inputs to the virtual machine. So here's those edges for the colors, expresses an edge and then a color, and then it's interpolated between those. Here is one opcode, which is basically just push the Voronoi noise on, and it's done with the fractal Brownian motion. So you get to sort of have a fractal version of Voronoi, and then it pushes on a bit of simplex and then multiplies the results together, and then it obviously does the coloring. So, and that just gives us what we just saw a second ago, which is this thing over here. I'm not doing bad, Geeko. I've had some like interesting news at work, so it's just my past 2 days have been a bit crazy. So yeah, some things have been shifting up at work basically, so I've just been dealing with that. One project is going to get actually can work in the past 2 days, but today I have the day. Awesome. Over good news. Well, it's kind of bad news. But yeah, it's okay. Like, effectively, I've been changed to another team. But I'm still a graphics programmer. So I'm no longer in my team at work anymore. It's been moved around. So, yeah. Yeah, well, at least I'm still doing graphics programming, just on a different team. I just would hope. Hopes to not be there long. It seems like it, well, the way it's been sold to me is that it seems like I'm there for a short-term reason. We'll see. But anywho, it doesn't, life still goes on, still got a job, still at the same company, so things are still good overall. So I wanted to test out the fractal for running noise just to make sure it was okay. So I'm going to switch up to material 3 where we've got the testing grounds. And we'll put in a bit of, right, FBM Veroni. Now I'm going to grab that Veroni noise from above, and I'm going to, I want to grab these inputs. FBM, FBM. And what I want to do is visualize it in grayscale, and that's what we're going to see here. Because grayscale, because we've just been viewing it as color, and and with the different edge, or different gradients based on the predefined edges we've defined. And I would like to see what it looks like in grayscale first. Alright, so let's visualize what fractal Veroni noise looks like in grayscale, and we'll play about with the values, F, B, and M. Alright, so there's our fractal Veroni. I do remember it was coming up a bit white anyway. That was because we probably had the light on it, wasn't it? Yes, it was. Looking alright, isn't it? It's like so you got the Veroni outline, but you've got, it would be easier if I guess let's view it as sRG. Sorry. Yeah, let's turn off this linear to sRGB thing, so we can at least just see more of it. It's incorrect, but we can at least see more of it. So what we're seeing is the Veroni outlines, but then there's more Veroni that go inside it and they kind of get accumulated. So we just, it's a fractal, isn't it? So let's just play about with a bit. So let's turn off the octaves down to 1. Just want to make sure we're getting a good... Oh crap. Oh, what's this noise function? Does it return... It should return 0 to 1, so we shouldn't need to do this then. That's okay. Wonder if I need to put that SRGB conversion back on. Okay. That looks dope. Look at that. That's just with 1 octave. And then when you add another octave, it basically does another sample of the Veroni noise, but at a smaller, at a higher frequency. Yeah, higher frequency. And then it sort of adds it in. So that's where you get it again basically on top, and you get it merged in. So we're seeing 2 layers of Veroni now. So that's actually looking alright. So we're seeing another set of patches here basically. And you can change like values like these, like the lacunarity. And it sort of just changes how just changes how the pattern works. Makes it more spread, I think, something like that, or more other way to describe it. Right, no, it makes it more yeah, smaller, quicker, doesn't it? Yeah. Right, so that gain, then that's an interesting one to play around with, actually. Right. Yeah, so that you could either add stuff on gradually. Or just up the number of octaves. That's going to keep adding it more on aggressive and aggressive and aggressive, so it gets brighter and brighter and brighter. Well, that's pretty neat. So that's if you have the gain up there. We have the gain about 0.3, so it recedes as it, yeah. That's cool. Yeah, I'm actually happy with the FPM function for the Veroni. I think that's really good. We're able to achieve a lot with that. You know. So let's get back to the to-do list for today. So yeah, that was one of the things on my mind was, did we implement the Fractal Veroni well? So it seems good. It seems very usable. That is for sure. Cool. So the next thing I want to try and generate is tree bark. We've generated like lava, right? I would like to try and generate a bit of tree bark. So we've got this one to have a play around with. Now, I think the way we've got to generate tree bark is like, so I wanted to avoid this because I'm using a octahedral map for the texture. So the octahedral map means I can take a normal direction and I can store that into a flat 2D texture. So rather than taking a normal direction and storing it in a cube map, it's stored in just one flat 2D texture. So that's great and everything. We know it works well. We've solved all the problems with that. It's just the way I want to make the tree bark is they added another thing called scale. Now scale, if I just scale some, say we should probably just go back to the Veroni noise for a second, and let's not make it fractal. We'll bring the fractal nature about it down. Okay, so imagine if this is tree bark. We'll obviously change the colors. So the problem if we did it, well, we could do it this way, just by changing the scale. And then we have two poles. Yeah, maybe that's okay actually. Yeah, no. Yeah, so you have two pole areas here. So what I might want to try for a second is like, if we go to using spherical coordinates, and you will get the artifact where it sort of bunches up at the top. But I think we can smooth in some other noise. And yeah, we could maybe lerp, we can lerp in a regular noise without the so let's put this back and see if we can generate that sort of tree bark. So if I say two spherical coordinates from a normal, right? Then if we just run that, okay. So you're going to get those poles, right? One on each side. Now, oh, not easies anymore. Interesting. Or I'd like to... Oh, radius thigh fader, this is completely wrong. Right. No, maybe it is right. Why is it switching it around? Doesn't change anything. Oh, it has changed it. Right. X or YZX. Can that do it? I wonder what would change where the poles are. Oh, okay. Have a look here. There's that seam there as well. It's horrible. Actually, no, that seam even exists? Oh, it does exist. Yeah, so I was thinking... Hey, Merva, how you doing? Welcome to the stream, sir. I'm a bit cut off on the camera and that one out. Welcome, how are you doing? Yeah, so let's try its spherical coordinates, save a stretch along the Y. Or the X in this case. Definitely multiply more near the top there, isn't it? So I was thinking what we could do is say if the normal is near the top, then sort of blend in another noise, so sort of smoothly get rid of this part. And then it would just stretch this all the way around. I think it's possible. The problem is I've just got to get it to rotate properly. And it seems like... It seems like it's more stretched on one side. Maybe not though. No, probably not actually. Okay. So why is it specifically pointing down with the x-axis or something like that? What's going, or the z? What is going on there? This year I kept wishing game mode would end faster, so I'd see these insane, absurd shaders. Did you have like a game? What do you mean by a game mode? You play with some friends or something, or is it at work? I did a programming exercise recently for procedural map generation and got down a rabbit hole all about noise generation, smoothing functions. Super interesting. Yeah, you can do so much stuff with this. That's why we're making a very general shader. That's just exposed a bunch of options. So someone who doesn't program can just hopefully make quite a lot of things with it. And yeah, you can just combine noise with other noise and color it and get tons of different... Oh, I think we can get quite a lot of different materials. We want to try domain warping as well in a bit. That'd be an interesting one. Yeah, Thursday's game night. Nice. What game did you play? have you guys got a game which is not like a free game that you play? Because that's how I always end up with my friends, is someone would not be interested in buying a game, so you'd have to play a crappy free game. And then, we'll just be sitting there playing Fortnite or something, just, just to socialize. I hope that one day ends. So making your own engine. Yeah, definitely. Why not? Why not? Monster Hunter. I played some Monster Hunter. I played New World. Well, not World. What's it called? Sorry, Monster Hunter World. Yeah, that was a good game. I played it. I got to the end basically of the main set missions, right? And then it was on PS4, right? And PS4 had that thing where if you didn't turn the console off properly, magically your save data could be corrupted, and it happened. And for some reason, my PlayStation Plus wasn't set to auto upload save files by default, so I lost my whole save and I didn't play it again. But I had some good times. It was just a bit insane. Hey Lupo, welcome sir. But yeah, Monster Hunter World was good fun. Honestly, I played Monster Hunter on PSP, but I was too young to figure out how to play it properly. Yeah, I gifted like 3 of my friends games to force them to play. Exactly, it's the way you got to do it. Even though you're just playing Fortnite. And you got to deal with people building stupid towers because they can't play a shooter without building a tower. Mustafa's ended, can't do the bombs anymore. No. Missed all the gifted subs yesterday. Got some more gifted subs from Crimson Mania, which is awesome. We played the hell out of Let Loose. Oh, what's the Let Loose? And Counter Strike. Yeah, Counter Strike's good. Oh, hell, Let Loose. Right. It's like a World War II. Maybe World War II. Oh, it's published by Team 17. Interesting. Oh. Right. Kind of reminds me of like Valve's version of this ages ago, like Day of Defeat or something like that. You should play that. You should play that. But yeah, Counter Strike's a good game. I just remember I collected a bunch of crates, and I didn't play it for years, and they've just gone up in value, so I just sold them, and I had like over £100 in just Steam money to spend on games. It's a good investment. It's playing Counter Strike apparently. Just you get a bit of free money to buy future games. No, I take turns buying a game for one friend. Cannot afford it. To avoid that, awesome. At least you guys have a strategy. Yeah, yeah. Honestly, the amount of like if you could extract money out of Steam legally, it would be you'd have people like who will basically just buy and sell stuff on the Valve stock market. Yeah, case money. Exactly. I still got some case money left over. I just missed my chance of buying it in one of the Christmas sales, but maybe there'll be a summer sale coming up. Yeah, I wonder why. I wonder why this noise is centralized around here. Because so we convert to. Can I swizzle these geezers around? No, apparently I can't. Oh, okay. I've got it. Right, I've turned it on the X, isn't it? Is that what's... No, because it's all okay. It always wants to go down one axis for some reason. Ow. Yeah, maybe I've got this a little bit wrong. It can't be. That looks right. It's a length op. A turn 2 wide. You might have to do something like that. Right. Oh, I've done some maths in my days. Right, so it's facing the top now. This is a seam. No, there's a seam. Yeah, bastard, there's a seam. So yeah, I'm okay with a bit at the top. I think we can get rid of that by smoothing in some other noise. But I'm trying to... Like, there's a seam there, which means that if someone do like sine and cosine, how it's... Oh yeah. I'm using a damn 3D noise now, isn't it? Well, shouldn't I just use a 2D noise now at this point? Like, if you select spherical coordinates, what you're actually looking for is mapping a 2D coordinate and not a 3D one. That is true, isn't it? So, perhaps we might need 2D equivalents of... Okay, that's interesting. No. You still have the same problem, isn't that right? Like, you have the seam. To the edge of the texture, there's a seam. I didn't think you'd have this problem with spherical coordinates, but of course you would. Would you get it with simplex? Well, it's not. Yeah, it's one large file, but it could be bigger. Think about rotations and 2 rotations. One axis can look like, makes my head hurt. Right. Same. I also like, when I read messages, I also like put my own words in there, or, you know, or miss words entirely. So, yeah, my reading ability is like, you know, could do with some work, but, you know, English is my first language. Just cut me some slack. Yeah, so there's a seam that's introduced here now. So I guess let me just try and solve that problem where we blend the top. I want to see what we can do there. So the way I would solve that problem is it's like, say if, so what we're saying is if the dot product, that would be cosine of angle, wouldn't it? Or something like that. Cosine angle, wouldn't it? Then you can arc cosine it, get it back. Yeah, so let's just say A. Maybe the dot product with like an ABS of normal, right? So it means we'll get the one pointing down and one pointing up, and we're trying to dot it with 0, 1, so it's pointing Y, yeah? So you will get 1 back, basically, if we're pointing directly up. Now, that is cosine... Oh wait, sorry. If they're pointing the same way, you get 1, yeah. If they're both normalized, you get cosine angle back, right? Yeah, cosine angle. So if you arc cosine, to get the angle back, Do we care about that? Well, equally, we know we probably don't. Yeah, let's just say just get cosine angle. Then I think so. And I think in this case we can do a lerp between spherical coordinates and then regular coordinates with a smooth step. Like 32. So we're going to say, is it smooth step? Yeah, we probably want to say something like we're remapping probably from 0.75 maybe to 1. We'll see. We'll throw in. So I'm wondering if we can smooth in a regular noise. Okay, it's interesting. It's made this sort of circular thing, which is what we kind of got anyway. Right. So maybe we can't smooth in. Yeah. Right, okay, creates like a... Right. Okay, let's just give up on the spherical coordinates. Let's just go back. Okay, no more spherical coordinates. What's the other ways we can make bark? I think sometimes cosine... So, cosine rewired us programmers to want highly structured syntax. We're skipping Sartogan. Oh, right, so you're saying. But yeah, that might be it, right? Yeah. Programming has rewired our brains to just basically skip and look out for important information. Yes, basically. Right, so we change the scale on the Y, we can get that, I guess. The problem is you got these sort of poles, but I guess they look like that. What I would like to have this, but then equally it going vertical, you know. That's what I'm saying it. I would like this pole at the top here. But then this all to carry on going up. That's why I wanted to go with the spherical coordinates. But we got those seam problems. Yeah. Oh, I wonder. Could you do two Veronis with different... So what way is that? And then you combine them basically. It's not the way I wanted. And yeah, do a multiply or something. Perfect. Right, so I reckon we can make two Veroni noises. Exactly the same ones. But the scale's different. And then you combine the result. Maybe. See how that looks. Pretty bananas. So you kind of want the one... Yeah. Maybe not. So you got that one and that one. And you could do a weighted average between the two. But then it would look, you'll get these rings that appear on all the... Yeah, it wouldn't really work great. It's not what you want. A mask layer. We could... Yeah, maybe a mask layer could work. Yeah. So like, let's just think of toggle between the two. So you don't want that pole there. But then you want that pole. Yeah, and then you want... And then at the top... Yes, all you'd be replacing is basically a pole at this point. One of these with sort of look like it's going up. Going across instead. Kind of, but I don't know if it will blend right. That's the problem with it. I think the mask might be a little bit too much. And if you do both, it'll just look weird when it will go across. Yeah. I'm not sure how we'll get the bark, to be honest, without the scale. I guess let's just try and do something else for a bit. Maybe I'll think about a solution. Another idea is to map the scaling with a spherical function and not linear scaling. Yeah, so I did map it to spherical coordinates a second ago. Is that what you're saying? Map the normal into spherical coordinates? I did that, but we had like seams and stuff, right? I think, right? Is that what you're referring to? We tried going to 2 spherical coordinates. But yeah, we get the seams, we got the poles, and we get the seams. Oh, for the scaling itself. How would that... Ah. Hey Pinkerton, welcome back, sir. So scaling it in... Right. So you're saying scale the Y or whatever in... And then turn that back into linear coordinates. Oh, right. Okay, I see what you're saying. So scale... Right. Maybe we give that a go. That might work. Just crashing. No, okay, good, good. How's it going, Pinkerton, sir? How you doing? Welcome, welcome, welcome. So what you're saying is... only apply this actual stretching around... Right. Yeah, okay, so I shouldn't really... Maybe I shouldn't be doing that ZXY thing as well. Let's put that back. Alright, so from the y vector, you're scaling the... Yeah, so scale the x and the z. Maybe. Yeah, so you're saying that the idea is to map the scaling of a spherical function, not linear scaling. You like alert, not hard cutoff. Full scale, some other arg. Yeah, okay. Yeah, so you're saying basically you want to say like where do you want to scale it? Like what areas of the sphere do you want to scale, whereas the others just leave alone and have it smoothly done so it wouldn't look so bad. I wonder if you'll see the poles basically. But yeah. Yeah, you just got to be careful. So how would you do that? So you could define a normal, right? And that would say, we could maybe say stretch in that direction. That could be it. Maybe just to provide a surface normal. And you could do... So we're saying if you're in that direction, don't scale it across. So the thing is, if you have this one, it's like, so this is like, it's straight along the x-axis. You have a normal going up. How would you take that and then get it to look stretchy? I guess maybe not quite, but that'll stay perfectly where it is. But when it's a little bit, yeah. So I think we could just define a normal and a dot product. Yeah, yeah, maybe just a dot product and a normal might just do it. So let's get rid of this scaling thing. So I think we'll provide some other things to the input, but let's just test them out here first. So you have a sort of a direction scale. So let's say 32. And then we'll have a direction. Right, stretch, direction, stretch. Yeah, some of that. So that'll be like a 0, 1. So say directly up, please. Now what we're planning on doing is modifying the sample point. So what we'll say is you do the dot product. It's kind of like a stretch. Is it an axis? It's not really a direction. It's more of an axis. But you can do it could be any normalized vector. And then see, you're saying let's just call it A. We want to do a dot product with sample point and stretch axis. Now I think we want to take the ABS of sample point, right? Such that it works on the other side as well. Then we're going to get a value between 0 and 1. Well, why don't we just take the ABS here and it'll be cheaper because there's 1 instead of 3 instructions, or 3 operations. So, right, now we get a value between 0 and 1. Now with this value between 0 and 1, we could probably define you probably want to have a stretch smoothness, maybe. And this smoothness would be defined between 0 and 1. And this will allow us to, so let's say it's sort of, or maybe call it, edge. Okay, I got ideas. So this gives you a value between 0 and 1. Now what we want to be able to do is you want to have that sort of scaled sample point, which will be the scaled version of sample point with stretch. Wait, how are we doing it? Stretch axes. Yes, that'd be stretch axis multiplied right, so I think it's an add with a scale of stretch axis and stretch axis scale. Yep. And now we want to simply just smoothly interpolate between these. So sample point is equal to the lerp between the scale, probably sample point, scale sample point, and then smooth step so the closer the normal is, no, there's a point in the same way it's 1, right? So I think we want to take the inverse of that. So at the end it's going to be 1 take A. So now we're saying, yeah, so we want to put in the, is it stretching itself? Maybe. I think it goes alright. So smooth step between axis 0 and that stretch axis smoothness. I think that's it. So if we try that out, that might get the effect that we want. The multiple things called A, which is, oh well. So we'll call this one I don't know. Hopefully, we get what we want. Right, so we definitely get some stretching. Pretty bananas. The wrong way around. We want this to be stretching, not this. It's got a little hat. Right. So maybe I don't need the inverse. I don't know why I didn't need the inverse. Alright, I need to inverse the smoothness maybe. Wait a minute. Okay, so let's think this through. So what? Hmm. So you basically want sample point. Yeah, it's this is I've put the stretching up to 32, that's why we're seeing it very sort of extreme. Interesting. Kind of changing the whole thing though. Oh, maybe that is right. Oh, but all I did is add. I've only added to the sample point, I haven't scaled it by. Needs to be a multiply in that direction, yeah. Right, now that's pretty funky. But yeah, it's not right though, obviously. We want it to be going up. So, right, I've stretched it along that axis, right. So maybe I guess you gotta get the perpendicular. Or maybe there's a way to stretch it. Yeah, maybe there's ways to stretch it across the basis vectors. X, Y, or Z basis vectors only. And I think we'll need two vectors. Maybe. And X, Y would be. Well, we did that thing before where it needs to be Z. Z. I wonder. Right. So we just need to do two. Right, so this is that sort of smoothing happening, which kind of looks all right. We are seeing the sort of it smoothing there, but we are getting these sorts of like parts here now. That's at 8. Times it by 8. I want to do 3 to see what it looks like. Oh, it's painfully wrong though. What's going on? You know, even a scale of 1 works out well. Oh, because these are multiplied by 0. Crap. Oh yeah. You have to add it on afterwards, isn't it? Maybe. Just write some random maths in and you get stuff that looks good. Yeah, then you're adding it on to itself. Okay, so then we're getting the stretching now. Or we should get it. It's up there. Right, there we go. So we've just introduced another pole now, basically, but this one is smooth. So what's happening is we're stretching along the x-axis is what we're stretching. We're stretching the sampling, and it's causing it to. We're stretching it along the x-axis or whatever the sampling, the rate that we're sampling at, which makes it look more squished. If we go the other way, did a -4, it'll actually go wider. Just go wider out basically. Now, oh, does it go wider? Let's see if we put -8. No, it doesn't. Yeah, it should be able to go both ways. I don't know what's going on with that. Scale is just multiplying by scale. Anywho, so I think the way we're gotta fix this is we have to get rid of these poles. We have to probably stretch it along 2 axes. So if we take in a y, so let's take let's do the actual 2 axes by hand, and we'll stretch along the x and the z, and that will make it look like it's stretching up. So axis A and B. So what we're trying to do is stretch along A. Let's call it SA. For some reason they'll have an SB. So we're taking the axes, scaling along the axes, and multiplying that by... Yeah, maybe we'll just have scaled basis vectors, maybe. I don't know. We'll see how it goes. And you're just summing those on. SB. It's gonna crash in it. Alright. Got a compile error. For some reason. Right. So in that case, you'll take the cross. Get that. Right, so by stretching along both the axes, we're getting this here, which doesn't necessarily look good. But yeah, here's me doing an interpolation here and getting that sort of like area up there. So I wonder what would happen if we just stretched both and didn't do this interp thing. And just called this sample point, you know. Okay, so you just don't get that thing. So like what happens if we sort of shrunk the top? Imagine a basis vector and multiply with your cache in now, right? Yeah, maybe we just take basis vectors and just allow you to scale those directly. So yeah, so you have basically scaling across the basis vectors, and then you could probably get this. No, you're doing it across the X and the Y. Yeah, it's not really gonna work, is it? Yeah, I don't think this one's gonna work. I think let's put a pause in it. We'll do the other features, we'll come back. Think about this one. But yeah, there must be a way to get this to work with like a bark. Yeah, it'll be alright. Do something easier. Let's just go back. Okay. So what other features did I want to add to this insane? I want to try domain warping. You know, I was also looking at other noise. Yeah, I was looking at some other noise libraries to see what they do, but right, so here we go. So I want to try the Voronoi hue shift based on cell ID. We could do that one. That shouldn't be too bad to do. Although we'll skip that one for now. Yeah, we're skipping that one. We've done this gradient one already. That's how we're getting this. Right, we do want to do the different channels. Maybe we get those in quick because they're required. We haven't got any emissive. We tried that the Y scaling. We've not been successful with that just yet, but we should be able to get it. Domain warping. I want to try that, like a recursive FBM. Offset the position by the resolve an FBM and keep doing it. So we're getting quite close. There's another few ones I wanted to do. So let's just quickly, rather than color edges, I think we want to have one of these for every single yeah, I think we'll call it noise color, but it's just or noise grad. Let's call it that. And we'll just pass it into a function and it will do it. But you know what we would like. Oh, we'll have a count as well. So grad for gradient. We'll have color. Albedo, which is what we're seeing here already. We have an emissive. Probably an emissive strength as well. And then your metalness roughness. So how do you remap a noise into these, basically? And then a metalness, roughness. I think that was it. Yeah, I think our output is a height. So lerp color space, what does that mean? That will happen in, obviously, the... Good me for maths for sphere, I got this. Haribo theorem states that it's impossible to define contiguous texture coordinates on a sphere without any poles. Sort the texture. Yeah, Haribo theorem, that is a bit bizarre name. But yeah, we don't have poles, right? Because we're using essentially like a cube map, but we're doing it on a octahedral mapping instead. But yeah, it's just the stretching really, is how do we do that? Yeah, maybe I've got some other ideas, but let's just get this one in. So we've got these different like color gradients now. Yeah. So I think we can make a... See, metalness and roughness, you would remap. Yeah, they'd be like 1D channels. Okay, so I reckon what we can do is input dot albedo. Oh. Color space is okay, lab. What other things did we do? And a colors edges count. Right. So what I would like to do for this to be emissive. Then emissive strength. We could probably get away with 2 edges on this one. Starting off at 0, going to 1. Just not really doing anything for now. So that would be 0. And then the other edge would just go to 1. Oh, wait. You want to go from... Yeah, but it's an emissive strength. That's not a uniform value. Right, we'll have to scale it at the end by some fixed value or something. Right, but we want it to be the other way around, really. We want it to be probably, in this particular case, right when it's low. Because this is where it's low, right, is where these parts are. And then as it gets higher... Well, we only want emissive for, where is it? Probably 0, we probably do want 4 edges. So yeah, we probably want it the most emissive here, so let's just say FF. Want it... Yeah, then probably actually goes to no emissive from there, so actually we do want 2 edges. Alright. Cool. So the other one was like metalness, and roughness. Now we don't really need a color space for those. Just linear would be fine, I think. RGB, these definitely need to be RGBs. 0, 2. So metalness was have one edge. Let's have it at 0. And then roughness, we could say, you know, we could have a bit of a thing where it shouldn't be very rough where the liquid is, but on the surface it should be rough. So we could have something like this. We take the emissive one and make that 4 channels. And have roughness. And so at the low parts where it's this sort of yellow, we should probably say it's a it's not rough at all, and it's not rough at all here either, but it begins to be rough here. Let's say it begins to be maybe half rough, and then it gets super rough at the top, right? That'd be interesting. So now we just need a standardized way to, at the end, after we do the sort of noise virtual machine thing, we've got this. We'll go over all the edges and generate the color. So at the end of the day, we're returning a color, isn't it? So we called it albedo, wasn't it? Okay, so we're returning a vector 4. Yeah. So we'll call this noise grad evaluate, and you pass in your noise function. Oh, so you're not the noise function, the noise result. So that'd be a value between 0 and 1 in our case. So we need to obviously pass in the noise grad as well. Gradient. Okay. So rather than input, it will then be gradient. So previous edge, previous color, we store the final color in, might be vector 3 actually. So that'd be like the final color. And then at the end, we just return the final color. Perfect. So now we've got this, evaluate the noise, the gradient for that noise value. Stick this up here, ready to use whenever you're just ready to use multiple times in the shader. Makes the shader get more complicated, but it's fine. So we call it albedo dot RGB is equal to noise grad eval. We pass in input dot albedo, right? It's the noise, the gradient for the noise, and the noise is, do we call it noise? What was it called in here? Height. Cool. Right. There we go. So all we need to do is repeat that. So what emissive, and then we have emissive strength. Now this one just needs the R channel. Then we have metalness and roughness. Those are the same thing, right? They just need the R channel. Now the thing is about the emissive strength is that it's going to be a value between 0 and 1. So we probably want to scale it by like 32 or something. I don't know, let's just pick one. We can always change it later. So if we try that out, we should be getting a really nice looking... Oh, that actually compiled first, it didn't crash. Okay, so it went a little bit crazy there. We probably want ways when we have the editor to debug stuff, but there's the emissive making it glow. So I think it's because I didn't have any roughness, maybe, and it might be just a bit too bright, so it's causing the other pixels to be... Yeah, it's caused like a kind of armor plating, isn't it? Yeah, it's not very rough. I think let's put the roughness all the way up, and that might help with it. So roughness. Let's say that the liquid's not rough, though. Right, that didn't really change anything. Oh, it's an OK lab. Should we do an OK lab? It's only for colors. Or I not got anything good for that roughness, I think. Let's do a 1 point. It might just be because of because we're doing like fractal noise. Oh, damn it. You know, we're getting a value of 255 in there. Oh no, I've done that as albedo, crap. Yeah, thank you. Good call. Yes, let's sort that out there. Just jack up the emissive again. There we go. Yeah, so it's made that look better. So yeah, we'll keep that one, I guess. Let's turn the fractal down. Make it look more lava-like. So that's the... so much emissive. But then turn it down in here. All of the emissive. Where is it? Emissive strength. Yeah, we turned it all on. That's not good. Let's put it at 32, I think that is. No, that's 64, isn't it? It's a bit thick, but it's okay. I don't know. So the edges there, brought that edge down a bit. There we go, it's better. And you'll notice here that in the lights, with the lighters you see a reflection of where you should be, of the other light, which comes from up in the right, because the roughness is low. It's got low roughness, so you see the reflections of the lights in the liquid, if you will. So that's cool. We'll keep that one. The image of shiny liquid is strange. Yeah. Well, you would get a sort of a shiny liquid, wouldn't you? Right? It wouldn't be. Would it be rough? Or would you have roughness up on liquid? But yeah, so we'll keep that. We'll keep that one, and we'll do something else now. So I'm glad we got those channels done. It's only have a single op. Let's do another one of these. So we'll change it around a bit. Do ops 1. I've forged and smelted metal many times. Awesome. And you can't see reflection in molten liquid. The emissive drowns it out. At least in my experience, right? Interesting. Right, so it's actually very bright. Maybe at least maybe these lights must be very bright, maybe. Yeah, I see what you're saying. So molten liquid would be it'd actually be much brighter than this, right? Interesting. You know, that's one of the things I was gonna get my dad and my granddad for Christmas was not sure if they would have liked it, but I think my granddad would have liked it, but my dad probably would have yeah, he would have probably found it interesting after he'd done it. Maybe he would have enjoyed it while he was doing it, but they'd get them like a day where they go and do sort of smell. They go and basically become like blacksmiths for a day and make like a tool or maybe a knife or something. I was not really thinking like a knife though because they're not really into things which are like violent. But I was trying to find one which was kind of local, and it would have been quite good for them to do, to be honest. But it was kind of short on money, so I didn't really do it in the end. But maybe next year. I think it'd be good. It'd be fun, I think. So you have you made some stuff, Marval? Have you done basically blacksmithing? Is that what it is? Yeah, it definitely sounds fun. Right, what's the next thing on the list? Domain warping. That'd be an easy one, I think. Maybe I speak too soon on these things. So, Indigo Coolers has a thing on it where you can produce stuff like this, basically. So what you're doing is, rather than just in a fractal Brownian motion of your simplex noise or whatever, you're taking the result of that and then applying it to your point and then doing it again. And you can get some like really crazy looking stuff. So if we add domain, like that's standard FBM. So that's basically applying simplex noise many times at different octaves. Sorry, different frequencies. And then this is what happens when you recurse. Yeah, you're kind of doing that again and offsetting your point. You can get stuff looking like that, and then stuff like this. So I reckon we can get. It just adds another way of getting interesting stuff. So we might as well put that in there as well. So I wonder how we can do this with the virtual machine. So this is how it does it with 2D. We just have to do a 3D one as well. So yeah, blacksmithing stuff. Been a while though. Stopped after surgery in my arms. Oh no. What what's happened with your arms? Did you have like an accident or something? Yeah, so I reckon he just picks random things to multiply by, I don't know. So they're different. But yeah, so if we had a domain warped, we want to basically have a domain warped FBM. So maybe let's call it DW FBM. And then it will just have a way of saying how many times do you want to do domain warping? And I think you should just be able to play around with it. Yeah, so I think what we can do is we can add another one called, just put it in the FBM. And you can just say, so there's octaves, and I don't know what you would call the other one. See, what doesn't the word octave even mean? Like you're given every iteration of the domain warping as an opcode itself. The recursion is the VM. The problem is those that mutate point. You'll mutate the position, and it won't be contained within just the noise you're trying to do. But yeah, it's a nice idea though. I think I've thought about that before. Yeah. Close though. So yeah, I reckon we can do something like that basically. And then you've just got to modify position. So then just say point. Now this is where it's three-dimensional. So what IQ's done here is changed his Q. Oh, so sorry, he's FBM'd. And then, yeah, so the thing is about these is you need to offset and scale them in different ways. And doing a fixed amount is probably not. I wonder if you can get anything. So that's one FBM. Then you've got a result. Then they're doing another one. Yeah, see, this is not really this equation that he put up. Right, and that this is a bit misleading. This is kind of separate FBMs. If this is the interpreted version of the noise VM shader, we just need a JIT version, an AOT version, and all will be the worst place again. Oh yes. Yes, virtual machines. They are, oh, for programming languages at least, the most pointless thing I've ever known. The only cool thing about it, I guess, is it's kind of sandboxed, kind of, isn't it? So you can control what happens when something invalid happens and your program doesn't crash, and you can make a kind of a safe environment. But maybe we could have had some of those things in hardware or in the operating system, you know. Yeah. Maybe they didn't have to be done in software, in user space. I don't know. So I think we could just play about with basically just adding to point based on, like, I don't know what we do. We'd say right, so it's whatever P was before. Yeah, so it's taking P. Yes, essentially you want the original P, basically. So you want the OGP. And whatever the result is from this, so it's a value. So essentially it'll be value maybe the user can provide their own sort of domain. Yeah, this could be configurable, so this would be the domain warp. Domain warp offset, something like that we'll call it. That might just be enough. I don't know, we'll see what we can get just by playing about with. We'll probably do it as a grayscale as well. So we're back to FBM. And it'd be domain warp. Yeah, exactly. When you see, you see. You know, because, yeah, I think I put it in there because there was like tons of people always come in talking about like new languages and stuff, or like, you know. And Fossabot just puts everyone in their place, so. Good lad. Like there was just, I think it was like every stream got to a point where there was like a new language. You know, someone would ask about either Zig, Odin, or whatever. You know, Jai, and it'd just be every stream there'll be people talking about, oh, but this language does this and that one does that, and it's just a forever conversation that just kept going on and on. Like I was tripping on some highly illegal drugs, so that ended, which is great. It's an okay conversation to have like every now and again, though. But yeah, it's just gets a bit much. Alright, I think we'll be in a good place. Let's test it out outside of our crazy virtual machine thing we've just been making. Let's test it out here first, so we can see it in black and white. So domain warp octaves, let's start off on 1, and then we'll have some random offset. It's funny, I tried it like 20 times now without talking about C, and just type in carpool and yeah, C is a fab lang. Users did contribute at some point, but I gave up. Oh, fair enough. Interesting, you actually contributed to the compiler. Nice. Yeah, Zig is like, you know, they do some like cool stuff in the compiler, right? But it's just got too much comp time business going on. You know, everything, you see comp time written everywhere. And like, you know, U31, right? Like, proper like, you know, look to the like standard array, whatever they call it, like array view or whatever silly name they've come up with. And they're like, I'm just looking at the comp time madness that's going on. And it's just bananas. You can get by without like, I feel like we just need a cleaned up version of C, and that's probably good enough. You don't even probably need templates. You just need vectors built into the language. Probably like the way Odin's done it, to be honest. Odin's pretty interesting the way it's made arrays have the sort of swizzle syntax. It's a nice feature. You know, all we need is basically that plus C. Remove all the crap from C. Keep everything basically the same. Maybe sort out the macro system. Honestly, sometimes header files are nice. You know. Sometimes good header file, you read it and you're like, ah, beautiful. But yeah. Right, so up the number of octaves. Sorry, domain warped octaves, if you can call it that. But the problem is with that is that actually we can't do it here because it's not recursive. What it's doing is it's not reset these things back to their original values. So we do that, and then it'll be recursive. Yeah, it wants to replace C, but oh my days, what have I done? What have I done? Oh, I've reset value, that's the problem. Frustration is a different place. Oh, we did it. Look at that. Oh, isn't it lovely? Different place, that simple place, so they're not replacing it. Yeah, so see, that's the thing, right? Rust, people are like, oh, it's a C replacement. And it's like, no, it's a C++ replacement. And that's what people don't understand when they say, hey, we're here to replace C. So you're just replacing C++. The whole point of C is that there's not much to it. And you know, C is actually, if I was to take a look at C, I always use a subset of C, right? Because there's some stuff in C I'm like, this is just silly. I'm never using that. I had a lot of fun with Odin in the past. Yeah, Odin's probably my language I would probably go to if I was in the, you know, there is a reality with, you know, if you're gonna make a game that goes across all the platforms, you probably don't want to pick Odin. But that's the problem to cross when you've made a successful PC game, probably. And maybe you just transpile it to C, and that's the way you, one of the things you need to do to port it. Right, so the problem is with the domain warping, I think, is like these probably need to be, the offset probably needs to change for every single like. Oh, no. Hey. The value is what you used to do the offset. Yes, the value does need to be reset. very true. It's more like it. Oh, it just went to dust. What have I done? See, that's going to accumulate the value, but then crazy high detail though. Oh, that was pretty neat, isn't it? It's like a drawing. It's very artistic. He says you can't do art with master. And this gets a bit crazy. Yeah, ship it. That's a nice texture. Sort of change the scale and voila. Getting a lot of aliasing there. For some reason, I don't know what. Probably the MIP selection. Anyway. The Rust become more complex C++, in my opinion, especially the threading stuff. Yeah, with all the futures and stuff that people do, right? Crystal growth. But yeah, we've got to mess around with this thing a bit more. I think it's still a bit off. There's something about it. When I do another one of these, amplitude and the frequency. Do these just get mutated? Then we should reset the value back on a successful. Yeah, there's something about when we do another. I think that's okay, to be honest. I think let's sort out the simplex one so it reads the same. Oh crap, we're gonna. Gotta be careful to non-const a domain warp octaves as well. If not, it's going to unroll and it'll be crazy for performance. And reset that as for the simplex one. Right, I guess we could try the simplex one out. But yeah, I think we need to change the offset. We could cycle it. dw offset equals f dw offset y zx, and just that would just cycle it around basically, and you know, just shuffles it. It's yeah, that might do it. Might just be enough. I think I just broke. No, I didn't. Okay, so yeah, that's just applied domain warp on top of domain warp, and it's just gone crazy. I guess if I change these, what happens if I shrink these by 4 times or something like that? Right, it's just That's cool, man. Barrel shift. Yeah, that's it. Early crack open a crystal, right? Gotcha. Man, that's cool. Like a drawing. You'd obviously have to turn the scale down to see it from far away or something like that. If you want that, but you could do it. Stuff like that we could do. Man, there's so much good stuff you can just do with noise. It's incredible. So if we increase the number of... Yeah, so if we did that and increase the number of octaves, that's just going to get a little bit too crazy, is it? Yeah, I think, you know, perhaps... Sorry, the domain warped octaves or whatever. Yeah, so for Voronoi noise, you probably want to be really careful with just doing multiple domain warps, but it has its purpose. It's just... No, this is sick. You could just do so much cool, interesting stuff with it. It just looks so bizarre, but yeah, there's stuff you can fiddle around with. I'm happy with that. Should we try the simplex, not domain warp now? Yeah, exactly. Just got to put the colors in. Get some psychedelic looking stuff going. Right, so let's turn these octaves down and see what we're sort of playing with. So, yeah, that's not quite what we'd want. Probably want to scale it up a bit. Oh, the gain is just too low. So with Voronoi noise, you need to have a gain where it reduces, whereas with a simplex noise, what you want is a gain where it increases, and the lacunarity needs to be smaller. What's going on? Why am I seeing it change? Has it just crashed? Right, I think we broke that. Oh, the crap, man. You know, let me go back to the Voronoi noise just a second. I want to see what happens if we don't do the shift here, because I don't know if this is a good thing to do or not. Because that will keep doing it in the same way, wouldn't it, basically? And... Right, definitely adds more sort of randomness. Right, let's check it out one more time. See what... Yeah, I think that looks better. Let's not do that shift thing. We can always put something on if it seems that way. Right, so there's a thing with the lacanarity. Was that changing? It wasn't changing anything to do with what's going on here, or even the gain. And I wonder if that's... I see them... They were working before. Let's go back to 1 octave. Gain. Oh, we ain't got the octaves on, isn't it? Of course. We're not multiple octaves, so therefore it's not. Oh, spicy. Nice. Here we go, some good stuff with this. What does the barrel shift do to the normal lava texture? Not sure. Well, you would have to see, I guess. That would do to that one. But yeah, it was for the domain warping though. We're not going to be using domain warping for the lava one. Yeah. Exactly, you can make like marble looking stuff basically, yeah. Right, let's go back to that simplex noise and domain warp the crap out of that one. So you want a little bit of gain. So we wasn't actually doing octaves, that's why. Far less lacanarity, I think it's like 1.6 kind of thing. You probably want to have some degree of scale. Let's put the octaves, the domain warping octaves down. Right, that's not what we want. Oh, I need more octaves. I was hoping for a smoother looking thing. What's going on with this simplex? Is the scale too much? Oh, of course. It's -1 to 1 instead of 0 to 1. So we're not getting the values that we want. It's slightly different than our Veroni noise FBM. I really need to put that down because they are different and it's annoying. -1. Whereas this returns 0 to 1, it's a distance. Distance to edge. Cool. So what's going on here? We need a little bit more. Just make it a little bit less bright, but just monkeying around with that. I'll help us see stuff for now. I guess we do need a bit of a scale. Let's add more octaves. All right. Let's try and put the domain warping on now. So let's domain warp it. Nice. So we can monkey about with the Let's make one of them 30, see what happens. Okay, let's make another one like 20, see what happens. Right. Okay, so you just monkey around with like these octaves basically and these parameters to get different looking things. So you could probably make this reduce the gain so it will shrink. It's less defined, that's the problem. Probably want to reduce the lacunarity maybe down to something smaller. And that wants to sit around 1 as well, to be honest, doesn't it? If you did that, yeah, maybe like a 0.9 or something. Oh no, you just change the scale if you want it to be bigger, isn't it? Yeah. Cool. Yeah, it's interesting. Yeah, you can get some funky stuff with that as well. Right, that's a good feature we've added. So there was some other ones as well with, there's some other things you do with FBM. There's a couple of different modes you can do. Which want to probably look at those. But yeah, we're nearly there with it. So I think what we want to add these different modes to the fractal brownian motion, and then probably take a look at trying to do that bark texture again. And then I'm probably just happy with this shader, and we just need to get some UI on it, and then it should be good enough. Cool, I'm just going to take a quick little break, and then we'll resume when I get back. Alright, welcome back everybody. Yeah, so I was just thinking if for a second, like, these domain warp offsets, the user might want to provide different ones for each. octave maybe, if that's what we want to call them. So what we're going to do is index this with I and just see and like feed in some manual ones and just see like how different can it make it look. Okay, so if we were to provide, let's say, alright, so that still runs. Okay. Right. So, what we're kind of trying to do in here is... Right, so we make this instead like a 20 and then a 1. What happens there? I don't want to do anything. Oh yeah, 0, 1, because it's only doing 2 octaves, isn't it? Let's do 3 octaves. Right, so put that back to 2, then put that to 3. That's definitely going to change it, right? Obviously it stretches out a bit too early, doesn't it? Yeah. I wonder if you want this sort of control, to be honest, or not. Yeah, it's probably okay. Cool. Right. So what's next you want to try is probably try and generate that sort of bark texture again, because I want... Yeah, I want to... I want to be able to at least make bark with this, or something like that, you know. Somehow... We just made the sun. There's no loop going on, there's no domain warp. The same site with the star rendering I sent link for the other night. An article about noise to make. I was using to make a gas giant. Interesting. Interesting. So with the gas giant, you've got a lot of like refraction going on, is that right? Not refraction. You got a lot of like subsurface scatter. Is that what you call it? Oh. Yes, well, I don't know. Maybe. Maybe. Oh. See, I want to try and do the stretching. Oh, maybe. See if we can stretch an axes. Yeah, so the thing is about these. Yeah, maybe the domain warping can be tweaked a bit more. I reckon I'll do for now. Yes, leave it. We got so much time. So I want to try and stretch the... I want to try and make bark, basically. So if I change the colors to like... Let's get rid of this red. And let's try and aim for more of like some browns. Yeah, this is kind of... I remember last stream when I had it in dark mode on a color palette website. And I was, yeah. The values I got back was not what I wanted. Right, so we kind of want like... Have probably more... You probably want sort of like green in the lower ones, maybe. Yeah, so I think let's do this for the sort of hires. So 8C. HCA 093. Oh, right, this one here is 545A. 69. And then I want to probably try... Should have gone for that one. That's alright. It's just a test, isn't it? So 22F and 3D. Oh, wait. Okay. Right, next one, 15, 20, 2C. Right, so we take these colors again. Repeat the same one for emissive. We're probably not going to have any emissive, though. Right, so you could probably get by with having just black and one edge, color edge. Then again, one color edge that's completely off. The emissive strength, metalness 0, roughness, we're probably looking at being rough all around basically. You know, it's wood. It's pretty rough. So you would just say that's all on. Right. So now we've got the... Okay, so it's not quite... It might work out alright though when we stretch it like crazy. Yeah, this is, I guess, the colors. Why is it coming out kind of greeny? Did I... HC... HCA0... the wrong way around. HC... 93A0. There we go. Yeah, really is. Anyway, see how it goes. This is meant to be some wood, I guess. So we want to try and basically stretch the Veroni out. such that it's we don't have any poles, but we want it to be will we say like a cylinder? Or we have a sort of a kind of a flat part at the top maybe, and then where the sort of cylindrically where it sort of is not those areas, it's stretched along the y-axis or something like that, right? So maybe we could map it to a cylinder instead of a sphere with that. No, because then we've got the silly wrapping. Alright, maybe we need to get into Supercore doing game dev on Linux. My perception is that most just used to using resigned to using Windows. Yeah. Yeah, I've always liked Linux and open source. I do think it's a great thing. I think they're better than Windows. Everything has its problem. Software's ginormous these days, and Linux has lots of fragmentation issues, and installing stuff as a system package manager is probably not a good idea. But Windows is more and more a steaming pile of crap, and people will always just complain about it. And with Linux, if you're a programmer and all we need is a web browser and a text editor, it's quite alright. Does the job, gets out the way, doesn't have Copilot trying to pop up, isn't slow as crap. Like Linux is like, put it this way, on my home PC, it's far weaker than my work PC. And my work PC runs Windows. It has some extra stuff on there, I think, for for security and stuff, but it's just so sluggish in comparison to just using Linux. And if more people were to use Linux, maybe, I don't know, there will probably be more developers if more people were to use Linux. Maybe it'll be more competitive to Windows. Yeah, but people get kind of a bit snobby though when you mention about Windows or using Linux. People on Windows get a bit snobby of like, oh, it doesn't do basic things such as, Anyway, does the job. Quite like it. Also, dev use Linux, more use Windows. Devs use Linux, more use Windows. I've been using Linux exclusively for decades. Yeah. I've been using it since I was like 14, I think. So, yeah, for more than half my life now, I've been using Linux. And basically staying on it because it's just great. I did use Mac for a bit though. About the Snow Leopard days, 10.6. It was alright. So it was back in those days, it was like a more functioning, cleaner version of Linux. But then they started doing crazy stuff when the Mac line came out and stuff like that. And Mountain line. Hey, Paclarap, welcome, sir. How you doing? Let's figure out how we're going to do the super stretch. So imagine this is a sphere, but let's just treat the problem in 2D for a minute. We've got normals, right? Or as my var found, it could be called a hairy ball. We've got normals. Yeah, for C++ plus, I find Linux easier. Windows. Yeah, exactly. Yeah. The development Linux feels just like it's just superior. If I was trying to stick like an end user on Linux, probably not a good idea. So how we're shading this is we've got a normal, right? We've got a point on the surface basically, and it's got a normal, right? It just points off the surface. And that goes, you know, on all for every single point we try and shade for this sphere. This gets mapped down to an octahedral map, right? So it's like a, yeah, this octahedral map is pretty awesome. Well, it's different than that, isn't it? It's like a kite. Yeah, so you got each of these octants, if you want to call it that. I think that's what we call it. Will map to a, you know, yeah. Like, if you're just looking down on the top of the sphere, it would do a 1/8 of a sphere basically, right? Each of those. So that's what we're mapping it down to in texture space. So we've got this normal. The way you can treat the normal is as if you're drawing a line towards from the center of the position, center point to the surface point you're trying to shade, and getting a vector to that and normalizing it. Well, it's already normalized because it's in the unit space of a sphere. So the normal is basically the same as a relative position to that point anyway, right? Cool. So now we know those things. What we've got to try and do is achieve a stretched look across an axis. We want it to get bark, probably using Voronoi noise like we're using here to shade this. Yeah, the mapping is cool. It's what people use for GI these days, is they use an octahedral map sometimes. Depends on, and sometimes spherical harmonics, which is something I still need to wrap my brain around. Mesmerized playing basketball for the next. Oh, I just use it in wine. The only downside I've got is that I'm on a 4K screen and it doesn't pick up on the DPI scaling properly, which sucks. But other than that, it's a really good tool. So I just download the Windows exe. So, if we got a position and we try scaling it across. So I was trying to do a thing where I picked a normal, a direction in which to scale it in. And I wanted it to sort of like, or looked stretched in that dimension sort of thing. So to do that, you probably have to take the perpendicular of that one. And then when you sort of, yeah, and then you change the sampling position along the X. As you increase it, they'll scrunch up more. But then the problem with that, yeah, I just feel like we've got to do it in spherical coordinates again. Because if we just stretch it, let's go back to something. Right, here it is. So if we just stretched it across the x-axis where it scrunches it up. Does that, looks alright, doesn't it? But then you got this. Bum, 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 bum. Yeah, I wouldn't say that looks like wood. There's still stuff to sort out. But yeah, it sort of goes all the way around and you still get these sort of poles, and that's okay. But I want the poles to be where I wonder, right? Could we get a pole up here instead? But then we tried that. And then you sort of try and get it to... You know, we've done that by trying to make it go spherical coordinates. So we're in 2 spherical coordinates for that normal. I had to change this around in here so it was ZY. Otherwise the orientation would have been wrong. So we're getting that pole at the top now. And I was thinking I could solve this problem. So what's happening here is that you're in spherical coordinates. So the x-axis, it now goes all the way around the sphere, right? And you're going to get a seam actually right there as well. Yeah. Something else to solve is the seam there. So it goes all the way around the x-axis and then wraps all the way around. And that's the value going 0 all the way to 1. Oh, we have to divide it by pi maybe, do we? Yeah, I don't know what we've got it. No, because it won't repeat. You can get a seam, isn't it? You could mirror it maybe, but then you get a mirrored texture. Oh, you can they actually have it. It's open source. I didn't realize Milton was open source. Right. Yeah, that'd be cool if we get it native. What about the predomain stretch for any function? What do you mean by predomain stretched exactly? Where I'm applying the scale at the moment, good question. I'm just applying it before I... It's in the Voronoi noise right before we do all the domain warping and octaves. So it's pre-scaled. I just pre-scale the point. Input. Just the input. The output wouldn't make much sense in terms of stretching the result. Right, was that one of your suggestions? To scale the input? Yeah, so that seam... Ooh. Or is there's 2 seams to deal with? There's that seam and this one up top. I think we can deal with this one. In that case, you could scale the Y here. I think we could do that. Right, then that goes all the way around, which is fine. You got to deal with that top there, though, which I think we could... So the problem is the x is the coordinate which goes all the way around, and when you get near the top, x goes around so fast that it causes it to be very different in a very small space. So yeah, we could probably mirror it at 180 and then get rid of that seam, I think. Do a mirror to repeat. And that will cause it to get rid of that seam, and then we just have to get rid of that problem at the top. So I reckon we can say we're doing spherical coordinates and then have some sort of like, and that will allow you to sort of stretch the y-axis maybe. I don't know, would you want to stretch the x? How would that look? Could you HUD or visualize the pole positions and the angles of the axes? It'd be like axes, basically, like an axe. That'd be the plural. Yeah, I could probably visualize it. I've got debug tools for that, but like I can debug draw from shaders quite easy. But yeah, I'm not sure how useful it would be. So it might be useful though. But it's quite obvious what they are, right? On a sphere. Right, that pole position is up there and you know, just a normal off a sphere surface. Oh yeah, I was just trying about the stretching, wasn't it? It's like okay. Interesting, so that it's a really big number. Doesn't really change much. So if you were to put it in, what about the Z? The Z's the radius, isn't it? Oh, alright, so why has it gone there? Yeah, radius shouldn't have gone into Z. Is that stretching it along the X? That's interesting. My spherical cause function is just wrong. Phi theta. Yeah, that's better. Yes, that'll do nothing. 12 will go up. So we could say do it in spherical coordinates. And then we could also say, and then we'll offer two scaling options, right? So you can do things like getting it to go around. But then why would you want it to go around like this? Maybe you would. Yeah, maybe we'll keep the scale anyway, regardless. So the thing is to fix the seam. So the way we fix the seam is you just probably ABS normal. Then if you ABS, it will do it. See, all we care about is the... What one is it? So you've got the X. That's the Z plane. Just the X, I think. No, it'd be the Z. It's the Z, yeah. You want the Z to do a mirrored repeat. So what you want is sample point.z equal abs, and that'll fix that. Yep, getting tired, huh? I was hoping to do like a mirrored repeat there, but... Oh, a mirrored repeat. Yeah, it would just be an ABS, wouldn't it? Shoot, what's going on? Still that seam there. It's been in the dark. We can't really see it too well, but... Did I just make another seam? Yes, we're hoping to see it reflect and repeat here. Let me remove that just for a sec. Oh, Z's the radius. Oh, wait. I think I meant to have done that on the normal. And... There we go. So we've got a mirrored repeat now. So it might be a bit obvious, but it fixes the seam. Yeah, so you do see a bit of a mirrored repeat here. But it might be okay. So you don't get a seam there anymore. When you use spherical coordinates at least. And then you can provide a stretch. So say 16. Right, so that's the... Now that's got a sort of a, you can't see the mirrored repeat too well. There's a mirror right there, but you don't really notice it. That's where the mirror happens. Now, all that's left to do is fix the poles. I was thinking about doing that interpolation thing. So, hey Voodoo. Yeah, it gets to a point where it just feels too long. I'm definitely like, need to get a haircut soon. But I have to shave my beard anyway, so I'm just probably just gonna... Yeah. I could just trim it. Maybe I should try and sort of just grow a beard out, Yeah. It's got to sort out the... Oh, is there an equator seam? Oh, there could be, couldn't there? Is there an equator seam? Let's open up the texture viewer. We'll see the seam in the texture if there is one. Yeah, that's where it is in the mirror. I'm seeing stuff. I can hear a damn buzz. Oh, okay. Sorry. Yeah, so that's where the seam was, but we fixed it by doing a mirrored repeat. And it's not really noticeable when you stretch it, so I think it'll be okay. So yeah, there's no seam. We're just gonna fix the poles now. So with the pole, we tried that sort of like we know where the pole is, right? So what we could do is say, you see, we just want to change that sample. If we just change the sample position, remember it didn't quite look right. It added some extra artifacts. But we can give it a go again. So I think we did something like the dot product between the normal and, directly up, basically, right? And then you probably want to ABS that result. And then, so that gives you a 0 to 1 value now. Oh crap. 0 to 1 value, 1 near the top, and 0 be directly at along the XZ plane. So I guess we can smooth step the normal again. Yeah. So sample point lerp between, so you want it to be at wherever the sample point is, and then between the old normal, based on smooth step between two edges. So the edge would be based on some kind of smoothness, wouldn't it, really? Let's put the smoothness at. I think we tried this and it didn't look well, but we'll try it again. And do full 18 hours, taking health. Give my mobile wife. That's organising to a school having heavy cough and colds up. Yeah, the texture is pretty insane, isn't it? We had some really funky looking ones earlier that were pretty insane. I think I can maybe toggle it on. You'll like these ones. I was messing around with domain warping. And they're pretty funky. So here's some domain warping of the simplex noise. And then you can also do like domain warped Veroni noise as well. Probably a bit too many octaves there. Yeah, it's just like a drawing basically. It's pretty cool. But yeah, pretty neat. So yeah, you guys make some good textures later. Future Henry or future artist person who finds using the engine interesting. They'll have some good fun, I think. Whenever that time happens. Right, so smooth stepping from towards 0. And what value do we want? Yes, whatever that smoothness is. Yeah, maybe we can say 0 to whatever smoothness, right? And then that'll be like a one take CA, I think, is the way to roll. For a wood material? Oh, yeah. Oh, there would be actually, maybe. Yeah, for like a, yeah, like an actual wooden plank type of thing. Yeah, interesting. Maybe it could be, right? You super stretch the noise out along the y-axis or whatever, and then you like apply that a few times, maybe, yeah. Oh, it's a domain. No, not domain warp. My brain is tired. Just trying to fetch the next thought. Yeah, so right, I think we just got these the wrong way around. I think. Okay, there we go. Right, this is kind of what I want. Kind of. So, yeah, it's going all around, and then we're getting... Although we are clearly seeing the mirrored. Oh. Yeah, we're clearly seeing the mirrored repeat show up, though, making that a lot more apparent. So maybe we'll have to solve that problem better. Might be possible. Oh, like not on the wood. Yeah. Yeah, so I've got a smoothness value, so you can change the smoothness. At least. So you can make it go up higher. Hairy Wookie. Yeah. Are these like some butt cheeks? What are these? But yeah. Hairy Wookie. But yeah, so we could... So something we could probably do as well is maybe square the result. I don't know what it will end up like, but you could probably monkey around with stuff like this, or power, throw it to the power of something. Oh, for crying out loud! What have you done? Yeah, that's with the repeat, isn't it? That's the reason why it's happening. Just trying to solve that repeat problem. But yes, squaring it will give it a non-linear. It makes it non-linear, right? Whereas if we don't square it, it makes it more linear. So it really makes this part bigger. And that'll be smaller. So if we did the square root instead, you'll get the opposite way around. That's alright, isn't it? Yeah, so as it make like a bit of a flat top, that's pretty alright, isn't it? It's kind of what I wanted, actually. I just got to deal with that mirrored repeat problem now that we've introduced, because, yeah, pretty alright. Good old square roots. Squarespace. Real thought. If you manage to make faces, remember the 80s where those plastic balls were printed like that with a weight, so the face always looks up. I don't remember the 80s because I'm not that old, but if you got a picture of something, of one, maybe I will remember seeing it or whatever. Right, how would one deal with this mirrored repeat problem? So I needed to mirror repeat such that I could deal with... And can I rotate the seam around so it's in the sunlight? Graphics. Where is it again? It's in the find model. Load model. Find or load. That's it. So if I rotate the quaternion around just a little bit, around the y-axis, half of pi, pi plus half pi, think that ought to do it. That'll put the seam right at the front of the camera, I think. 3/4 of the way around. No, it's just going around the back, isn't it? All I needed was the quarter pi, the half pi. I think. No. Oh wait, I've not got rid of the mirrored repeat, so of course we're not going to see it, are we? Shaders. Let's get rid of that mirrored repeat thing, so we can see the seam again. Right, so was that quarter plus a half? Could be useful for some marble game with ball-like creatures. You know, maybe there will be a way to put faces on. Right, is that the seam? Yeah, there's a seam there. Yeah, you can see that seam. Look, that's horrible. That's all got to fix. So I solved it like a mirrored repeat. And interestingly, the more that goes round, let's get back into the shader code. So the mirrored repeat. Right. So if I instead did POW. Right, POW. Right, this to the power of 0.8 maybe. Alright. There's something about this that just feels wrong. Why is the smooth step? Maybe I powered the wrong thing as well. So I guess this is when X is... Oh, that's just because there's a very big thing and there's lots of smaller things. No, it can't be like that. Okay, so if we just got rid of this, what does it look like again? All right. Yeah. There's still two problems to fix again. But yeah, we've been getting close. But it'd be interesting if we could solve it. Side note, you have text rendering. Maybe if shader is balked, you can show the compilation error in the game window rather than crashing with a grey background. Yeah, currently just crashes. I've just not solved that problem. Because the problem is that it overwrites the shader file. What does it do again? What the reason why it crashes, to be honest. I just haven't bothered looking into it. I just wrote it and didn't fix it yet. Yeah, it's using the y-axis. So yes, looks right. Really like your approach of trying to grasp and track all in your head, working directly with the code. But personally, I would go mad without additional markers and splines showing me what's going on. Right. Yeah, no, I definitely do that stuff when it comes to it, but yeah, I try to visualize it as well. Obviously, it's a bit harder for people to follow when I just visualize stuff, but in this case, I think it's quite simple because it's just a sphere, right? So if we were just to visualize n, that's what we get. And it's kind of doing a smooth one of that in between that, right? Apparently. So my next thing is like, let's take this and just hard code 0.5 in and see what it looks like. So let's encode 0.9 and 0.1. Right, it's definitely very... I know why. The damn stretching along the axes. Right, so what's happening is we're changing the normal. And what we want is the stretch to only apply. Yeah, so we're only changing the sample point, which is the normal. And this scale I'm applying to the FBM itself. That non-uniform scale. So when you give it a different normal, when we give it the normal, what's the way of explaining it? And we're stretching the y-axis instead of the y value in spherical coordinates. So x value in spherical coordinates goes round the sphere like this, and then the y goes sort of up. Yeah, that's why they all meet here, because it just goes up until it meets here. Whereas you're taking that sort of the basis vector x, y, z, and you're stretching the y-axis, that will cause the x it to look like it's circling really fast, because you're sort of kind of sampling the y quicker, and therefore that it's kind of like the xz plane. It will get a sort of a circle around it. So what I need to do is not do non-uniform scaling in the FBM, but if we have this spherical thing on, I think there'll be a spherical scaling that you could do. It would be x or y. So this would be the scaling. So in our case, we wanted to try and do something like 16 on the y only. And then that would be then multiplied sample point dot x equal multiply equals scaling dot x. Yeah, I reckon we got this. Oh, I just gotta get the smooth step back that we had before. Right, what's going on here? I think the 16 is just far too much. I thought we had before was this 6. So we've just got the seam. Is that just the seam to solve now? Like what's going on? Why is it? Right, so again, sampling point is okay to scale here, isn't it? Because that's the spherical coordinate sampling. Let's put it back to a bit of a play around again. Right, have a good one, Paklarep. Good to see you. Thank you for popping by. Have a good evening and have a good such a weekend. Hopefully see you some other time. Right, so going to n, you would just get that, and then all the way to sample point, you'll get that. Right? Right, so lerping in between them might be a bad idea next. So the other way would be the thing would be, right, is that you get the two results. So you run this VM twice, and then you lerp the result. That would do it. But then you just got to solve that seam problem. Maybe you could mirror it, and it might just work out. Right, so let's do that thing where we actually run this twice. I don't know if that's possible. Well, this is a function call, right? This is going to make this shader way slow, but it's only used for build time, so it's fine. So we ran it twice, and then took like then lerped the results. No, because if you lerped the results, you would basically see, it's like an alpha blend. Yeah, that's not going to work, is it? So maybe the way in which you do the smoothing is not from 0 all the way to there, make it very big. Maybe there's like an edge. So the edge would be there and the smoothness would be 0.01 or something. Or 0.1. So you'll go from edge, take, smoothness, then edge plus. And that might be what we need. It's crashed again. Oh, because I called it edge. Whoopsie. Is that asleep too? Soon, stay for a bit more. If we do fall asleep, can you please screenshot fix polls in Discord tomorrow? Will do, if I end up fixing them. Oh, that's interesting. So maybe we could just do something like that. So there'll be like, I could sell for that maybe. You'd need you get a ring though. And then a rock like that. So maybe the idea would be you get very smooth like that. Maybe you don't need the smoothness. Maybe you just cut it. So it's just either 0 or 1. There'll be an edge. And just cut. That also just works. Maybe. There's that seam though you gotta solve. Still. You can see it's right there. We only don't see it that much because it's stretching. But yeah, maybe that could work. You just sort of have a... Maybe, I don't know. Yeah, it could be, but then you want to shade it a different color, isn't it? Because it's like an inside. But you could do that because, well, how would you do it? That's the problem. You don't have different color channel things based on the... It's all got to be shaded with the same sorts of things is the problem. Yeah, this is one approach that we could take to solve the pole problem for stuff that wants to stretch. So what's interesting about that is you can make the edge bigger and you could get sort of bands around things as well, right? As if there's like 2 layers that have gone on. Although they'll have to be the same color. So this gets to the thing of like, it's definitely a hard edge though. Yeah, that's the problem, is the smooth step doesn't work for a normal, which, yeah, they're in 2 different coordinate spaces. Yeah, the sample points are in 2 different coordinate spaces. It's not going to work well. Yeah, it didn't work well, did it? But so with this, it makes me think maybe an idea is just to have multiple, like you could just cut it out like that. This looks a bit bizarre. But it can lead to some other interesting things. The other way is to have maybe multiple layers somehow and a mask, but then you're adding even more stuff. So you could do this sort of noise thing, and then you could probably say, yeah, I don't want to make this shader too damn complicated. But yeah, you could do this thing in spherical coordinates. Good question. I've only, it's at 3, let's make it 1. Okay. Doesn't look too bad. You can up that to like 12. But yeah, you get this sort of like hard edge here. So we could do a thing where we have like a mask and it sort of blends. between two different textures, basically. So you generate one texture, and then just basically generate another one. And then you need a mask somehow, so that's probably another thing that's generated. So that stuff is obviously possible with the whole sort of shading system I'm going to be building for this material. But for this super generalized shader, which just does it all in one pass with a bunch of noise functions, let's take a look at the data structure. Like you would need basically, so you've got one noise input. So it's got all these like these gradients for all those. How do you convert the final noise value to any of these channels, and then the operations that perform. So doing some noises and adding, multiplying, that sort of stuff, and lerping the results, and that could produce one noise layer, right? Or one layer, and then I guess you could do another layer, and then you'd need like a mask. But then these things could get quite big. But it's possible, right? You could do it again, basically. And then you can compute a mask, which will allow you to blend between the two materials. Yeah, maybe we'll add a layer system to it. It'll be quite bananas, but it'll be... You'll then be able to do this properly. So you could, say, put it in spherical coordinates mode, and then you'll be able to have... I don't know if the blend would look nice, though. Yeah, I don't know if it will. Yeah, well, they get the same as this hard edge, but you'll be able to blend the hard edge better. You'll be able to blend this in and out, so it wouldn't seem that crazy, right? So that's what it'll get you. You'll be able to literally like smooth step this, because you'll have the information underneath and above. You literally have the full texture done twice. Yeah, exactly like a selection tool. So you'll be able to do a lot more stuff with it. And the thing is about the mask, how would you make the mask? That's the thing. So you make the layers with just more of these operations. Yeah, it adds so much complication though. And then the mask, we would just do it based on the normal and the dot product, right? And then some SDF masks. But it's on a sphere or or on the surface of a sphere. What's the problem with it? Or you could do it intersecting with a sphere, whatever, but I'm just sort of thinking about the UI for this as well. It'd just basically be a list of operations, which is already kind of enough to visually comprehend. But then adding layers to this, we have another layer going on. And then a mask between those two things. It's getting a bit crazy. Yep. Yeah, spheres are difficult though. They're a nice simple shape, but a coordinate system on a sphere has its problems. So we could generate the mask with more operations, right? You just get a list of ops to generate a mask. But then that's just more silly complicated shader code. You know, you typically will want like the normal as maybe an input and a dot product of that with something, so you could do this thing. You might just want to take the noise, the result of the previous noise, and clip it off past a high value, and then be able to see through the material basically and see something behind it. You know, imagine these sort of like brown areas would just have holes through and you can see the layer behind it. That's something that's possible as well with a sort of mask approach. So it really is powerful. So if we added this mask and this sort of spherical coordinate part to this thing, it would probably allow you to do all the things you would. Yeah, probably allow us to do many more things. But it's just the UI I'm thinking about. So you generate a mask based on the noise. Yeah, you probably want a mask based on the noise itself, and then another mask based on the normal. So you could probably just code it like a smooth step. It could probably be a single operation. Maybe there's a bit like a blend mode op in rasterization. Maybe you call it like a. Right, catch the over. Have a good one, mate. You probably call it like a noise. Maybe you call it blend mode, layer blend mode, I don't know. And the way you'd probably do it is there'll be two for now. You have like a blend op. So one blend op would just be you take the noise, it's like a smooth step of the noise, heights. And you have like an edge 1 and edge 0. And then you have another one which would be a dot product of the normal and the dot product of the normal, and then again you have two edge values. Yeah, so you probably have that sort of, or you want to know like what is that? What is your blend? You could probably call it the blend input. Like, what is the input to the? Just make some mask. And then you could probably have ways to sort of say, like it does have more complication though. But you can have an edge 1 and edge 0. And then you could probably also have your sort of the PAL to change the sort of yeah. to change how quickly it changes. Rather than a linear, it's more to the power instead. Yeah. So if we added stuff like that and then made it where this would be a noise layer. And then you actually get the noise input back. And you have layers. And maybe we support up to we could just do 2 layers for now. But yeah, layers, there'd be a noise layers cap. And then you can get different colors basically on the layers. And it could be quite powerful. So the thing is about the layer is that they'll need a blend as well. I wonder how long this shader is going to even take to execute with all this stuff in it. But yeah, let's just say at most you have... you can do 4 layers if you want. So when it comes to blending, you will need... For every... You need the number of layers, take 1, isn't it? Noise layers cap, take 1. Layers count. That'd be pretty bananas, but it's possible. And then we'll be able to sort out this edge. It should be nicer maybe. Right, what I want to try and do is there's a mode. There's another mode you want to add. And that is the coordinate space. So the coordinate space would just be basically a standard one. Is the that's just standard what's it called? How do you pronounce it? Cartesian, is it? Cartesian space. That's how we call it. Yeah. So this one here. And then the other one would be spherical. Spherical coordinates basically. So we added that mode already. Sorry, we added the code to do it. It's just we need to put it in a nice if statement now basically. So for the layer, that's one of the options that you get is that coord space. There you go. Cool, so all we have to do now is add those layers in and do a nice blend. Right. So yeah, that's the thing as well. We probably wanted to remove, I think, the FBM scale. I wanted to make FBM scale probably like a unit scale rather than be a non-uniform scale. Huh. No, it will support non-uniform scale. There's so many damn options in this thing, but it could do a lot of things. And the other thing was, yeah, there's a scaling thing, right? It's like, oh no, you can do you wouldn't need this. You wouldn't need this anymore. Yeah, so this would just be like basically, you know, equal n if input dot coordinate space is equal to noise coordinate space spherical. We would just say sample point. To spherical coordinates. Okay, and then we get rid of that there. Cool. Right, so we're nearly there with this. It's gonna crash anyway. So we'll be able to make this sort of wood texture next stream. So next stream we're gonna sort out we're gonna make the shader even more complicated. We're gonna add support for layers, and then blend through the final results of the albedo emissive. You know, all the PBR textures before we write them out. We'll blend between the results based on the layer blends. And that will allow us to... Wait a minute, would we... Yeah, we'll have to think about it next stream a little bit more. But yeah, basically there'll be a way to blend between multiple layers in some interesting ways. And that will open up the door for a whole bunch of different interesting things that could be achieved with just this single shader. And then in that same stream, we'll probably just get that done in Sunday. But yeah, then afterwards we'll probably think about the changes I would like to make to the material system before we go ahead and do all of the UI for this thing. So we need to make a UI such that tweaking these values would be nice and easy. And yeah. So it'd be one of the first, well, it will be a second attempt at the first editor for this game, basically. So it's material editor, then a model editor, then a very simple level editor. And that will be what we'll be building this year, basically. Cool. Rightio, let's go ahead and find someone to raid. Okay. Avalago is streaming. Good. Right. Have a good Friday, everyone. I'll see you all hopefully on Sunday. Have a good weekend too. And yeah, there's there's Discord links and stuff in the About channel if you're interested in chatting off stream. But yeah, appreciate everyone who's supporting the channel. Appreciate you guys. And I'll see you in a future one. Right. Bye-bye.